Assalamualaikum warahmatullahi wabarakatuh. My name is Nurjana Farani binti Rusdan, KH20043. And my group members, Muhammad Azul Fadli, Muhammad Afif Shauqie, Nur Fatihah, and Nur Ain Fatihah. Today, we would like to talk about our mini project, which is the chemical equilibrium principle. So, for the presentation content, first, history of the chemical equilibrium principle. Second, definition and meaning of chemical equilibrium. Third, type of chemical equilibrium. Fourth, factors of chemical equilibrium with conditions and example. And the last is application of chemical equilibrium in industries. So I would like to start with the history of chemical equilibrium principle. For the history of chemical equilibrium principle, in 1803, the concept of chemical equilibrium was developed after Berthelot found that some chemical reactions are reversible. And then in 1865, Gilbert and Watch, building on the Berthelot's ideas, proposed the law of mass actions. In 1873, Joseph Willard Gibbs proposed that the equilibrium is reached when the system's heat free energy is at its minimum value, with assuming that the reaction is carried out at the constant pressure and temperature. Gibbs free energy, denoted by the symbol of G, is quantity that is used to measure the maximum amount of work done in a thermodynamic system when the pressure and temperature keep constant. In 1884, the French chemist and engineer Henry Louis Le Chatelier proposed one of the central concepts of the chemical equilibrium that states that Le Chatelier's principle is a change in one of the variables that describe a system at equilibrium produce a shift in the position of the equilibrium that counteract the effect of this change. And then the dependence of chemical equilibrium on external conditions is expressed by the Le Chatelier-Brown principle in 1885 until 1886. So, the Le Chatelier's principle helps to predict what effect a change in temperature, concentration, or pressure will have on the position of the equilibrium in a chemical reaction, and it is very important in industrial applications. That's all for me. Thank you.
Assalamualaikum, I'm Nur Fatihah. I will present the definition principle of chemical equilibrium. Chemical equilibrium is the condition of a chemical process in which both the reactant and product are maintained in concentration that have no further tendency to change with time, resulting in no observable change in the system property when the forward reaction and the reverse reaction both proceed at the same rate. This state occurs the forward and backward reaction rate are usually not zero, but they are nearly equivalent. As a result, there are no net change in the reactant and product concentration. Dynamic equilibrium is the term for such a state. At equilibrium, the two opposite reactions go on at equal rate or velocity, and hence there is not net change in the amount of substance involved. At this point, the reaction can be called complete, that is, the maximum conversion of reactant to product has been achieved for a given reaction condition. The condition that determine equilibrium can be quantified for the reversible reaction in reverse to be A plus C. For example, the velocity of the reaction to the right Ry is given by mathematical expression Ry equal K1A, where K1 is the reaction rate constant and symbol in parentheses represent the concentration of A based on the law of mass action. R2 K equal to K2B is the velocity of the reaction to the left C. At equilibrium, R1 equal to R2. The subscript represent equilibrium condition. The ratio of the amount of product and reactant present at equilibrium, and each raised to their respective power is a constant designed at the equilibrium constant of the reaction and represented by the symbol K for a given reaction at some specific temperature and pressure. According to the Lee-Chatelier principle, the value of the equilibrium constant varies with temperature and pressure. It can be shown that the equilibrium constant is related to change in the thermodynamic quantity known as the standard gauge free energy and comparing in the reaction using statistical mechanics and chemical thermodynamic approach. The negative natural logarithm of the equilibrium constant multiplied by the so-called gas constant R and the absolute temperature T equal the standard gauge free energy of the reaction, which is different between the sum of the standard free energy of the product that of the reactant.
Assalamualaikum. My name is Nafatiha. For the type of chemical equilibrium, there are two types of chemical equilibrium. First is homogeneous equilibrium. For homogeneous equilibrium, the reactant and the product of chemical equilibrium are all in the same phase or one state of metals. It can be divided into three types, which are the reaction where no net change of mole number of the system, mole number of the system increase due to the reaction, and mole number of the system decrease due to the reaction. There are a few examples of homogeneous equilibrium. Second is heterogeneous chemical equilibrium. For heterogeneous chemical equilibrium, the reactant as well as the product of chemical equilibrium are present in different phases. The poor solid and liquids are not included in the chemical equilibrium, which are concentration are constants. And this is the example. And this is the few example of heterogeneous chemical equilibrium. The decomposition of calcium carbonate into calcium oxide and carbon dioxide.
Hi, my name is Muhammad Afif Shauqie. Now I want to present about the factor of the chemical equilibrium. It's the five factor. First is the change in the concentration. When the concentration of the reactor or the product is modified, the composition of the mixture in the chemical equilibrium is changed. The example, if you change the concentration, the higher concentration, you get the higher the chemical, you can get the faster chemical equilibriums change. And second is the change in the volume. The equilibrium of the gases mixture at the equilibrium goes in the direction of a higher number of the gases molecule when the volume of the mixture is the raised. It means if you change the volume, you change the number of the molecule in the gases and you change the equilibrium chemical equilibrium in there. And third is the change is the temperature. If the two parts in the change the temperature is first is isothermic and second is endothermic. Isothermic, when the temperature is raised, the equilibrium composition in of and the isothermic reaction will tend to shift toward the reactor. And beside that, endothermic is equilibrium composition of the endothermic reaction will tend to shift toward the product. And third factor is change in the pressure. The reaction reverse the pressure is increased because the amount of the gases of reactor size decrease. It means the volume, you change the volume, decrease the volume, you change the higher the pressure, and the reactor reverse is occur. And lastly is the effect of the catalyst. A catalyst is a solution both forward and reverse process. It's the alternative way for you to most faster the route of to reactor to the product. And the pressure of catalyst not change the equilibrium constant the reactor. That's all for me.
Assalamualaikum. My name is Zulfadli Zulkifli KH 20009. So for now, I would like to present about the application of chemical equilibrium in industries. So basically, there are many applications that were invented by using chemical equilibrium principle. For today, I will present three main applications that have been successful in industrial producer. The first one is Haber process that produce ammonia, which is NH3, and the second one is contact process that produce sulfuric acid, and the third one is Ostwald process that produce nitric acid. So this is the model compound of ammonia, and this is sulfuric acid, and the another one is nitric acid. So let's go to the first one, which is Haber process. First of all, the Haber process is one of the most efficient and successful industrial producers of ammonia, which is NH3. The Haber process involves nitrogen gas from the atmosphere with molecular hydrogen gas to produce ammonia gas. The Haber cycle uses iron, which is ferrum, as a low catalyst. It allows for a reasonable yield in a reasonable amount of time. Ammonia, which is produced, is a product being used in various applications. The first one is ammonia is primarily used in the agricultural uses. Approximately 19% of all ammonia produced is consumed in this field. It's also used to make liquid fertilizer solutions with compounds like ammonium nitrate, salt, urea, and other ingredients. The second one is petroleum and mining. The second one is petroleum mining. Okay, so the ammonia is used in the petroleum industry to balance the acid constituent of crude oil. It also used in the mining industry to extract a variety of metals. Next is explosive. Ammonia produced is used in the manufacturing process of uh, nitro-based explosive such as TNT and RDX. The last one is medicine. It is used in the production of sulfoaminates, anti-malarials, and vitamins like thiamine and nicotinamide. Nicotinamide. Next, one of the most popular or common methods for producing sulfuric acid, which is H2SO4, is the contact process. The process also This process also produces sulfur trioxide and oleum um, in order to bring a cost-effective way to make sulfuric acid. There are some applications of sulfuric acid are useful in industrial such as paint, detergents, and pharmaceuticals, which are chemical manufacturing, which is highly important chemical compound that is used in the production. Other than that, sulfuric acid is used as an electrolyte in a dilute form to allow electrons to flow between the plates inside the cell, which referred as battery acid. The third one, sulfuric acid used as a catalyst in the refining of crude oil, and it is used in a sulfuric acid alkylation unit or SAAU. And the last one is metal processing, which that sulfuric acid used to removing impurities during impurities process. So another one of the most widely used methods or chemical process for producing nitric acid and HNO3 is the Ostwald process. Okay. Nitric acid is used in a variety of applications, including fertilizer production and the production of inorganic and organic nitrates of nitro compounds. Vanadium pentoxide, which is V2O5, is frequently used as a catalyst. There are some applications of nitric acid that are useful in industrial which make fertilizer. The fertilizer industry is the main factor of nitric acid production. Nitric acid is used in fertilizer production to create calcium nitrate and ammonium nitrate, among other nitrogen fertilizers. Coating is another application for nitric acid. It forms a clear varnish in the absence of pigments, which is primarily used for furniture decoration. Besides, noble metal like platinum, gold, silver can be purified and cleaned using nitric acid When combined with HCl, which is hydrochloric acid, it produces aqua regia, which can dissolve gold and platinum. Last but not least, acid nitric also can make many different types of explosives that can be used by military grenade weapons. That's all from me. Thank you.